Greetings. Welcome to week 2 of CSC550 Data Communications and Computer Networks. Today we're going to delve into talking about network devices, IP addressing, connecting computers together. Yeah. We talked about the point A to point B. We talked about sender and receiver. This is basically saying that, okay, well, how can we uniquely identify these components that are part of communications? So if you look at the diagram, the key things that we're going to be covering today is network devices in action. The router, the switch, the access point, firewall. What are the purposes of it? Introduction into IP addressing. We will not do a deep dive in IP addressing, but we will kind of touch on what it does, what are the major components, and how does it work. Okay. Then IP address structure, specifically what each part of the IP address means. IP address classes, what is the purpose of them, what is the bias, private IP addresses. Not every IP address is public. Not every IP address is accessible through the internet. There could be private IP addresses within the local network themselves. Talk a little bit about that. Subnetting basics, talking about how do we take a network and, depending on size, break those into smaller networks to make it more usable, more efficient. So we'll be talking about that. Default gateway and DNS, the quickest thing there is the DNS. Most important thing is DNS. Excuse me, and that is the name system. And that's taking basically a name known within the network and taking that and converting it into an IP address. For example, you might say, my email is stedmanm@carolinau.edu. That's a domain name. Okay. If we take that, we convert that to an IP address. Now we can access various nodes and communicate with various nodes that are within the network. Okay, so default gateway and DNS. Then let's look at some practical applications. So that's basically what we're going to be talking about. Basically, what's saying here: network devices, IP addressing, subnet basics, and connecting networks. Okay. Okay, networks in action. I'm put my glasses on so I can actually see. Okay, the key thing here is basically looking at the first of all some of the terms. Yeah, network service, client, server, protocol, port number, authentication, encryption, cloud service. Look at those definitions, and from a high level, be sure you know what they do. Okay, a server, a device, an application, or a device or application that services resources and data to the clients. Okay, so getting just a general feel of who the players are, okay, in the network services. Here we're talking about user action, DNS service, DHCP service, HTTP, and HTTPS as far as the internet, and the web server. Okay, the various definitions or what each one of these does is developed here. Take a look at those, become familiar. Okay, when you see the term, I am mostly wanting you, if I wouldn't say if nothing else, but one of the key things I want you to be able to do is when you're having a conversation with someone about networking and you hear the term DNS service, okay, you know what that means, okay? And so you can have a conversation and a communication understanding what the terms within the networking world mean. So make that a high priority on you to just become aware, okay, of the terminology. Okay, here, network services at a glance. We talk about DNS, transform a domain name to an IP address. The DHCP automatically assign IP addresses and settings. HTTP, HTTPS delivers web content. FTP, STP These are transfer files between systems. These are various ways that we can pass information from point A to point B. SMTP sends email messages. We're probably all familiar with that. And then POPs and IMAP, as far as emails are concerned, retrieves and synchronizes data. And then SSH, secure remote access and management. So again, key terms within network services. Each one of these is basically falls into that service category. So take a look at those and again, become familiar when you hear the term. You've probably seen it, guaranteed that you use HTTP and HTTPS, but just kind of think of it in the realm of in this networking, I guess, conglomerate of things. Where does it fit in that big picture? Okay. Behind the scenes, we have devices, the routers, the switches, the firewall, the protocols on interfacing with those, security services. Okay, so here behind the scenes are things that you definitely will not see on the surface, but which have to be there in the background in order for things to work. Here, common network services and port numbers. HTTP, okay, a port on your computer. You have various ports, which is basically points where you can send information out. In this particular case, HTTP is normally a TCP protocol, and it comes out of port 80. Okay, HTTPS out of port 443, FTP out of port 21. These are defaults. Okay, these are just in general. Okay, when you're transferring information, what is that exit point out of your internet, out of your system that basically is going to be reserved for knowing that if I get something out of port 21, it must be an FTP send. Okay, so defaults that we're going to use periodically as far as information coming in and out of the system. Service, the other ones, POP3, IMAP, DNS, okay. The default ports, okay, 25, 110, 143. The key thing here is not that I want you to remember that so what's in port 22. The key thing is that you're aware that there are ports that have specific service responsibilities. So when you're talking to someone and they say, oh, yeah, that'll be coming out of port 55. The key thing for me is for you to know that, that means that there is a default port that someone's sending information out of. You may not immediately know what that port is for, but that's easy to look up. The fact that someone says that they're referencing a specific port for sending and receiving information is a key to you that is a default exit or entrance into your particular computer or laptop. The key takeaway here, network services work together using protocols to deliver information and resources. Okay, that's what this is all about. All of these are service-related activities that for network services and how things are basically getting done. Okay, introduction IP addressing. IP addressing is the foundation of communication and networks. Okay, you don't do anything unless you have an IP address. Every node, think that you had a company that had 5,000 laptops, okay, and they're connected to the network. Each one of those 5,000 laptops has a unique IP address. Okay, now that IP address may be private, okay, or it may be public, but every node that's connected to the server or connected to the network, okay, must have an IP address. So that's what's being explained here. A logical address assigned to a device on the IP network. It uniquely identifies the device's location. Subnet mask, a 32-bit number that separates the network portion and the host portion. We'll be talking about that here in a little bit. Okay, the key thing here is this is the way the IP address is laid out. It has 8 bits, then a dot, 168 bits, then a dot, 8 bits, excuse me, not 168 bits, 8 bits, 8 bits, 8 bits. Each part of the IP address is 8 bits long, okay? So each octet, 8 bits, can have a value from 0 to 55. So I can have an IP address as 192.168.1.10. You will find that on your laptop somewhere, okay, on what your IP address is when you connect to the network. Okay, so how IP addresses are used, device creates data, data is sent to a default gateway, data travels across the networks using the IP address, again, which is the unique location of this particular device that sent the data. And then basically that reaches the destination device. Okay. But the key thing here is there's an ID associated with information that's sent to that particular receiver. Okay, when we're talking about classes, we're going to talk about that next as far as classes. So I'm going to hold off on that. But basically what is it saying here? A class is basically a classification of various IP addresses and how a range of IP addresses are basically reserved for specific purposes. Okay, and that's what we're going to be talking about with classes. Again, looking at one thing we're not going to get into is that right now, maybe later, but the concept of a bits. Okay, a bit everyone should know at this point in the current computer science, a bit is 1 or 0. Okay, hadn't changed, still 1 or 0. So this is basically, defining at the bit level. Okay, at the bit level, we're basically breaking those 32 bits. Okay, that are basically the total of an IP address, breaking those into 8. Now, am I expecting you to immediately know that if I'm looking at the second 8, what that particular value is? No, you can get there. I do expect you to know that the IP address is basically broken into pieces. Okay, and so those pieces are basically defined here. It says, used on the internet, globally unique. Okay, example 8.8.8.8. Private IP address. Okay, again, sort of thing, but again, it's internal. And loopback, okay, refers to local device itself. Okay, just basically, again, this goes back to uniquely identifying a particular device and where it's located. Okay, IP addresses identify devices and networks. Use private IP address for inside of networks. Okay, and routers uses IP address to again route data to where it should be going. Okay, so let's talk about classes before. Okay, so again, overview. Know that there's a structure to the IP address. Part of the IP address references the host. Part of the IP address is focused on the particular. If you come in here, the particular device itself. So we got the host, which basically owns the network, and then we have the devices which are part of the network and are connected to the network via the node. Okay, so IP address. Okay, key thing, everything has to have an IP address. Okay, the IP address structure. Here, this is kind of basically what we said before. A 32-bit logical address uniquely identifies the device on the IP network. Identifies network portion. There's a network portion to the IP address. These are the first 16 bits. Okay, uses to determine the destination network. Okay, subnet, again, breaking the network down into various pieces or various subnetworks for better organization. Default gateway, the IP address of the router interfaced on the local network. Again, even the router that's routing information, is anything that's connected to the network, okay, has an IP address. Broadcast address, don't need to get in that, but basically that's saying if I want to send information to every node or every device that's on the network, I can use a broadcast address. Okay. Again, remember I said a lot of these things I'm telling you about, the expectation is that it's basically putting things in the view or the framework where you see the overall picture. Okay. Okay, quick summary, IP version 4, okay. That's basically the most used IP address protocol. The IP address is 32 bits divided into a network portion and a host portion. The subnet mask tells how many bits belong to the network. Again, we're not going to really get into doing some subnetting, okay, unless you're a graduate student. I might be kind of pinging you to do that as far as an advanced feature, okay. But the subnet basically is a way that we can quickly, we have 32 bits, depending on what particular class you're in, how can I tell what part is the network and what part is the devices? Okay, so there's a concept called subnet masking, a masking process which basically eliminates those items that aren't networking. Okay, if I'm just looking for internet hosts, okay, or the vice versa. I'm looking for things to actually connect to the network and not the host. So I can do a process called masking. Yeah. Okay, here. The thing that I want you to kind of look at classes concentrates here. Okay. Based on the fact that basically a class is saying that not every place, okay, not every network, not every company, or not every, spectrum, okay, not every particular network needs the same number of IP addresses to be available. And so, for example, in this particular case, if we're looking at those that are in Class A, there's 126 gigantic networks, okay, that can use this particular IP address that begins with the first 8. If it's 126, I'm sorry, I always get fat fingered here. Okay, so here, if we look at the host had 8 bits. If we look at the first 8 bits, if they fall between 1 and 126, okay, then basically it can have 16,777,214. Okay. What we're saying here with the class is not everyone needs 16,777,214 IP addresses to address things that might be connected to a network. In your house, at Carolina University, that number is limited, okay? In the case of, say, Carolina University, we might be a Class B. In Class B, each network can handle 65,534. Okay. If I'm a Class C, which basically if I'm at home, okay, in my home network, then it's 254. Okay, so if we look at Carolina University, I probably would need more than 254. So I'm probably going to be falling in the B category, where I can basically assign 65,534 unique IP addresses to things that might be connected to my network. So that's what I want you to kind of get from the classes. That is basically just a way that the IP, the identification of hosts and identification of nodes connected to the network, okay, are different and are placed in a given class depending on how many connections you need. Okay. So that's the big thing about classes here. So here, again, key things, 16 million. Okay, here for Class B, 65,000 per network. Here, 254 per network. D and E, don't worry about it. Okay. Okay, so Class A, as far as Class A large networks, it has a few hosts per network. Okay, and here's an example of what the IP address might look like as far as 10.0.0.1. Class B, medium networks, moderate hosts per network. Example 172. So this is a moderate network. And then C are small networks like what you have at home. Okay, small networks, limited hosts per network. Okay, here we're talking about 254. So again, so the reason we have classes is just for the fact that every network is not going to need the same number of connections. Okay, so that's what's being displayed here with the classes. Okay, here just to be knowing that not all IP addresses are public. So this is basically kind of introducing you to the fact that there is such thing that is called private addresses. Okay. So in your conversation of networking, you have to make that decision. Is this a private network or is this a public network? Okay. So here private addresses are used, private addresses are used when private networks such as homes, schools, businesses, they are not routed to the internet. Devices use private IP addresses internally and a router to connect the internet using the public IP address. So there's a conversion of the private address with the public address. Okay, and that's what basically we're defining here. You know, what is the private address used inside, typically assigned by the organization? Network portion identifies a specific private network used by routers and switches to route traffic within the network. Okay, host portion identifies the individual devices inside the network. Must be unique. Again, that's basically any type of node that I have connected to the network. The IP address must be unique. Okay, for that particular device. Okay, other things here, you know, address structure example of a Class C private network. Okay. Key takeaway, private IP addresses are used inside the private network. They're not routable on the internet. Router with NAT translates private IPs to public IPs for internal access. So there's a conversion between the private address and the public address. Choose the right range size based on the number of hosts needed. Okay. That's whether you want a class A, well, the average person is not going to get a class A, okay, or probably class B unless you're a big company. But again, look at that as far as maybe when you're breaking things out into subnets, you know, how many devices am I going to need to take care of or be connected to a given network or a subnetwork? Okay. Okay, this concept we just see of subnetting. Key thing here is a 32-bit number that represents the network portion from the host portion of an IP address. Okay, that's during we talked about masking. The address identifies the entire network or subnetwork. Your subnetwork ID, part of the IP address that identifies public subnet within a larger network. Okay. Again, breaking that network out into pieces, into sections. Okay. So basically, you might say, okay, I have 1,000 connections I have to this network, but I'm going to break them into 250, 250, 250, and 250. Okay. So on this particular subnet, I can handle 250 connections. The next one, 250, so forth and so on. So basically, it's just a way of easily organizing the networks into subnetworks for efficiency, for maintainability, and for giving the number of connections that you'll need based on the size of the network. Okay, so keeping that in consideration, just as we have classes overall, because everybody doesn't need 16 million, that same thing applies within a company. I might have a subnet that needs 50. The next subnet uses 300. The next subnet uses 20. Okay, so it's basically being able to fit the size of the network into the needs and the number of connections that I need in order to do my business. Okay. Okay, so look over this page again. In general, where does subnetting fit into the whole picture? I'm really not saying that I want you to start getting into how do I develop a subnet specifically, but more that if I have a subnet, why? Why do I have a subnet? A default gateway. The key thing here in this section I want you to look at is the DNS, which is the domain name system. And basically that defining here, where are we? There we go. Here, as far as the name, domain name server IP address, the IP address of the DNS server that resolves domain names to IP addresses. Sorry. Okay. So basically, again, taking the name that I have internally for a particular node or particular device and taking that and translating it into a specific IP address that I assign to that domain name. Here, human readable name used to identify a website or a service. Okay. And we're taking that system that takes those domain names, basically tables them up to have a name and associate it with a particular IP address. Again. Okay, resolves IP addresses on the flip side when I'm having data come in. Rather, when I'm taking the data, it says, I want to go to IP address, 198.68.5.2. Okay, that is basically coming on the flip side, saying that is translates into a domain name that I'm basically going to be using to send the information to. So domain name to IP address, coming back, IP address to domain name. That's the key thing I want you to get to from this particular slide. Okay, understanding key fields for the default gateway and DNS and their purpose and how they enable communication. Okay, here, how they work together. Okay, this is kind of a flow where somebody's doing a query from Carolina U. Okay, DNS server, it responds, it has a IP address assigned to it. Okay, traffic here, okay, for that particular IP address, we're sending it to someone on the internet. So this query is going on the internet to get information here because when I get that information, the system will know, okay, I got this information on the internet. Who do I send it to? Okay, when we would have registered that the destination server is 192.0.2.10, which again was based on the fact that I took the domain name and I transferred it and created a IP address from it. That's what I want you to get. Again, I'm giving you the whole picture here so you can see that particular piece and what are the other things that are connected to it. Okay. But that is kind of the overall for week 2 in getting the information related to devices and related to IP addresses and how that connectivity happens. Okay, sounds good. Again, remember, I'll say this after each one. Be prepared for a short quiz on this particular video. So please look at the video. Don't want you to be dinged for something that is very easily avoidable. Okay, so we'll see everybody later. Have a good one. See you on Thursday. Bye.